All right, here we go. This is 9.3 overriding methods, but before we do that, we're going to do a whole bunch of things. So it's not just 9.3 overriding methods. We're going to add a little bit more. Some of it not on the AP exam, but still good to see. For first, checking some constructors. Let's do that. If you did the exercise, let's see if you were correct. Here is regular mail. Show the constructors, look here. Call in the parent's default constructor. Here is regular envelope. You got getting a feel for how these constructors should be created. Here is the regular box. Here's priority mail. Here is priority envelope. And here is priority box. Now, one thing here is you can see that the constructors pretty much look the same. Okay, just the name of the class changing. So I'm going to go back to the mail and kind of attack some of the issues we have with this API. So let's go ahead first and explain these little bullet points, and then we're going to jump into the issue with this API. So first, is-a versus has-a. Is-a. So for example, a mail is an object. If I go across to a regular mail is a mail. And if I go across to envelope, a regular envelope is a regular mail, and so on. You could see the relationship with the is-a right at the top, because that's what extends means. It means this is one of this type. Now, the other one that shows up as well is has-a. That's when you actually have an object inside the class that you're creating. So for example, string, from the object of a string, right? The string class, we have an object here. We've got two of them actually, from address and to address. This means that a mail has a from address. Okay, we don't say has-a for primitives. So double is a primitive, int is a primitive. We do it only for objects. So if you are creating a class and the class also has another object inside, we call that has-a. So what's the difference? Is-a is inheritance, has-a is composition. Is literally I'm composing this by using another object. It's kind of like building blocks. I took an object and I'm making another class who's going to also make an object. So, because remember, an object is an instance of a class. Next, single inheritance versus multiple inheritance. Well, Java does not support multiple inheritance. What does that mean? When you extend, you can only extend one class, one, single. So I can extend this thing and another thing and another thing. I have to extend one. So in our regular life, we will consider our extends to be two, because we have two parents. So when we extend, we're extending two. So not here though. Here we extend one. Some languages allow multiple inheritance. Java does not. Now, here's the other thing. There is another advanced topic called interfaces, which you can extend one object or one class. I shouldn't say one object, one class, but implement many interfaces. So that's another way of Java way of getting around the multiple inheritance. And now this is a topic that was taken out of the AP exam, so I won't stress it here. We will do it a little bit later in this unit. But moving on, I have a problem with this. Here's what the problem is. I'm talking about instance variable versus method. How do you know which one to use? And here's how I'm going to do this. Let's look at the first three pieces of information needed to create a mail. I need a weight, need a postage, and need insurance. Okay. So the weight is raw data. From address is raw data. To address is raw data. We cannot figure these out. We have to be given this information. But postage and insurance are not raw data. So let me go ahead and show that. Look at this. See, the postage for any one of these, you could pick any example, let's say here. It's $1.50 for any mail below 1 pound. So it's related to the weight, right? Because if the mail is a little heavier, it costs a little more. And this idea here suggests then that postage is not a variable, but instead it's a method. And the same is true for insurance. Whenever you see a formula needed to create a particular piece of information, that a piece of information is a method. How do I know that? Well, let's say we were to save in a database the date of birth. Age would be the method, because the age, you can calculate that from the date of birth. Same is true here. Insurance and postage can be calculated from the weight of the mail. Now, obviously, because that's true, that would mean that this API needs to make a change. Okay, and this is very common. APIs change all the time. So I don't want these two to actually be instance variables. So what do? Well, I'm going to get rid of them. So only weight that we need right now. So I don't need the postage. I don't need the insurance. I actually don't need them here either. So, because you see, I can't construct a mail with the postage unless I know its weight. So this is premature. Same is true with insurance. These are premature. I could calculate them after I've weighed the mail, but I can't calculate them at the same time. And this is when you construct, you want to do it immediately. So therefore, I'm going to get rid of these. Now, obviously, then my mail constructor changed. So these are gone. Okay, so what would that do? Well, when I save, we're going to have some mistakes. If I go down to my kids, the kids are going to be saying, hey, we don't have such super call. We can't call the parents because the parent does not take these two. So what we do? Get rid of them. So basically, I am getting rid of them because they need to be calculated after I get the weight. So I am going to turn them into methods. See all the arrows saying, hey, you need to get rid of this because these are not necessary at this point. So if you were wondering, when is a particular piece of information a method? When you can derive it from the raw data. Let's say that again. When you have a piece of information that is 100% derived from raw data, that becomes a method, not a variable. So it started off looking nicely, but the API needs to change because it's not going to work. And if you're wondering, well, how could it not work? Well, it's not going to work because if I try to create an instance of this class, I need the postage. That's what the constructor is saying. He said, hey, you need the postage to make it, but I can't tell you the postage unless you tell me the weight. So because that's true, I'm going to make those methods. Now, obviously, if the information changes, all I got to do is change the method block. I can create a new method. I can create a new way of calculating the postage, and the API still works. So I'm not storing this information. I'm calculating it. So I'm going to get rid of all this. Now, if you tell me the weight, I'm good to go. I can calculate the postage and the insurance. All right, so we got to look back and see what's going on. So I took care of all of that. You should have as well. Let me go back and see. So if you're looking here, you'll see things like, the postage is $1 in some cases, and then in the envelope it's the same, and in the box it's this weight times the regular postage. If it's less than, see all these little pieces of information. These are calculations. These are if statements. You can see them. So I don't want to do that as a variable. I want to do a method. Okay. So, couple of things then. First, not on the AP exam. I'm coming down the list here. Abstract class, not on the AP exam, was taken out, but I'm going to do that because this is the best way to do this. It's, even though it's not tested, it's a good way to see it. So here's what I'm going to say. Because of the specs, see, the specs right now are for everything below mail. Look, regular mail has a postage, envelope has a postage, regular box, everybody has a postage. What about the mail itself though? So the mail doesn't have a postage. If you look through here, you'll see all mail objects have the option of adding insurance. It's calculated based on the weight of the mail. So the weight of the mail is the most important part. Now, if you look through here, you won't find anything for this. So how would I figure out the postage for this particular mail? I have it for regular, I have it for envelope, I have a priority, I have priority envelope, priority box, but no mail. What does that mean? Well, the mail is too abstract. It's too vague. Because if I create an instance of a mail, is it a box? Is it an envelope? Is it priority? Is it regular? I don't know. So this is very vague. When you have a class in your API that's vague like this, like you can't figure out what type it is, where is it falling in the API? It's good to design it this way with this general idea of a mail, but in this case, we don't want to instantiate it. I don't want to say mail m equals new mail. And because that's true, I'm going to create this as an abstract class. So what does that mean? I'm going to just put the word abstract here. What does that mean? That means you cannot instantiate a mail. That's what this means. I cannot create a mail object. I know. Contradictory. I have constructors, but I can't construct it. That's a little weird. So what I'm saying right now is you can't say mail m equals new mail. Default or non-default. So you should then ask, well, what's the purpose of these constructors? To pass information up. See, this regular mail passes it to the mail. Okay? It's a top-down design. Same is true for no matter where I am in the API. Everything gets passed up to mail. Remember, construction goes like this. Objects first, then the mail, then all of its kids, and then its grandkids, and we keep building out the API like that. So this is very important, even though I can't instantiate it. So I'm going to make that abstract. Now, here's the reason behind abstraction, or this level of abstract class that I'm using here. So if I have something that's abstract, I can force behavior. I can say, if you are a mail, you must perform the postage and insurance calculations. So I am going to do that right here. So here's what I'm going to do. I'm going to say public abstract double calculate postage. Now, obviously, and then I could say public double, should put the word abstract as well, abstract double, and this time is calculate insurance. I want to show an error here. So this used to be on the AP exam. It went away, but I want to show something here. When you're creating these, what you're saying is I'm forcing my kids to perform this method. So I have two pieces of information that all kids must do. Here's the error. If I were to take this, okay, let me just kind of take this out, copy here, put it up here. Just going to show it, okay? And I were to do that. Let me actually comment this out. You'll see an error here. It's saying, if you're an abstract class, I'm not going to instantiate you, so why are you implementing this? You cannot do that because I'm not going to create a mail, so a mail shouldn't have any kind of behavior associated with it, especially with the abstract behavior, okay? You don't want to do that because you're saying the reason for this is my kids would do it, not me, okay? You could have a method in the abstract class, you can, but it can't be abstract, okay? So that's a little technical detail there. I don't want to actually implement it. What I'm saying is, my kid's going to do it. The other way to think of it is the parents going, hey, go clean up your room. The parents aren't going to clean up your room. You're going to clean up your room. So I'm forcing you to clean up your room, to do something. So everybody beneath me must do these. That brings us to overriding methods. Now, before I say anything about overriding methods, I'm going to say right above it, if you're not an abstract class, you're a concrete class. So mail is abstract, but regular mail is concrete. Regular envelope is concrete. How do you know? Missing the word abstract. Computer's always true, right? Is either true or false, on and off, if and else. Here we have another one. Abstract, not abstract. Here's another one. Static, non-static. Always two. So because this is abstract, it has the word abstract. And everybody else is concrete, which means everybody else are actually going to calculate their postage. So what I'm going to do then is say, okay, this and that must be done by everybody else. Now, the problem here is we need to override. What does that mean? Well, if I'm a male and I don't do my calculation like my parent, I'm going to override it. Now, you can override two ways. You can override by simply taking the method and redoing it completely without any help from my parent, or you can use the parent to help you override it. I'm going to show you both. So right now we have two methods that we must write in every class. Okay, so I'm going to do this. I'm going to copy them. Okay, and I'm going to paste them into my kids. So let me actually do that right now. So I have the postage. Okay, and I have the insurance. If you're looking at this point, let me actually, you would see that it's saying, hey, I can't say you did it because you actually didn't. I'm going to just return 0.0 just for now. Okay, I'm going to return 0.0. So right now my regular mail calculates the postage. Now at this point right now you would see an error under here. That's because the word abstract should not be there. Not a technical detail. If you are a concrete class, you cannot have an abstract method. Let me point that out. See, the reason why the word abstract is okay here is because this is abstract. But don't implement it. Just say what the kids are going to do. Put a semicolon right after. You can't even put a curly brace. Okay, that's wrong. You're just telling the kids what to do. So then the kids now are going to do it. And how are they going to do it? They're going to implement it. Now, every time I create this, I'm going to put it in all of the kids. Watch this. You could see that my kids are all going to get these methods. Okay. Every kid's going to get them. Because I'm saying if you're a male, you have to do this. Now, I did put them in everything, but it's not necessarily true that it's going to be the same thing. I just copied and paste to make sure everybody is doing it. Now, here's something that's very important. Okay, let's go back to the API and check this out. See this regular mail? If this regular mail performs the postage calculation, immediately these two beneath get that same method, meaning they inherit it. That's the idea of inheritance. So the concept of overriding is I can do that action just like my parent, or I can do the action a different way. The same postage, I can calculate it a different way. Now, how do you know the method is overridden? The signature has to be the same. The right across here has to be exactly the same. There's another technique called overloading a method where the signature is different, but here, signature is the same. Same public, double, calculate postage. Spelled the same way, same number of parameters if there are any. Everything is the same. So if you don't do this being the same, it's not overriding. So right now, if you're looking at the API, what I'm having here is I have the regular envelope overrides the postage from regular mail. Okay. So why is that important? Well, that's because based on the specs. See? So regular mail has a fixed postage of $1. Okay, so let's kind of like nail this in now. We're gonna do the postage. So I'm gonna go to regular mail, and it's saying this should be $1. I can just put $1 here, and that's done. Now you could do that, or we could create a constant. Okay. Let's call it postage equals to $1. And a constant is to be final. Now I'm putting it all together here. So I'm going to return the postage. Remember, this can't be changed, okay? It's final, so this is a constant. Can't spell the word constant. There's a constant. You can't change it. So that regular mail has a constant postage. Okay. Now, I could make a getter for this, but I can't make a setter because we can't change it. But I could also just simply call calculate postage. This is what I was talking about. When you override a method, you could have your parent help you. And I'll show you that in a second. We're going to deal with the postage. That's all we're going to go through. So let's go to the postage for a regular envelope. It says the regular envelope has the same fixed postage as the regular mail. Let's go to the regular envelope. What does that mean? Don't put it. If you're wondering, what? How do you mean don't put it? Well, you see, the regular envelope is a kid of the regular mail. And if the regular mail has a method to calculate postage, if the regular envelope doesn't have one, it's going to use its parents. It inherits it. So you could think of it this way. This method is not just here, it's also here. You don't see it, but if you create an instance of a regular envelope, you can call this method. That's the inheritance. See, if it was different, then I would override it. So the question then is, does my kid do method the same as me? And if they do, leave it. If they don't, override it. So right now I'm going to go back to the API. Look at this. The box, though, don't do it like the parent. It says the box has a cost that is weight times regular mail if the weight is less than or equal to 5 pounds. So I need to figure out the postage for the box. Let me go ahead, just the postage. So it says if the weight is less than or equal to 5 pounds, take the weight, multiply it by the regular mail, and that would be the postage. Otherwise, you're going to do 50% more. Okay, here's the tricky piece. I want the weight, but I don't have access to the weight. I don't have access to the weight because the weight's nowhere here. The weight is all the way up in mail. So you know what we do? We write a getter and a setter. See, I'm putting it all together. So I'm gonna write the getter. Public double get weight. And I know I could simply just GHT. And I'm gonna return this dot weight. See, what I just did here is the purpose of a getter. So now that I have a getter in mail, you know what happens? Everybody has the getter. See, the getter is all the way here. But everybody underneath now has that get weight. Why? They inherit it. It's in their genes. It's in their blood. They got the get weight from their parent. This got it from his grandparent, and he got it from his parent. So this get weight is everywhere. The word is all. When you put something at the top, the word is all. Right now, it suggests that if you are a male, all males calculate postage. All males calculate insurance. All males get weight. All. Not some. All of them. So if I go down here now to my envelope, I can write my, let me see which one we want. It's envelope. It's the box. Let's go ahead to the box. I can write my thing right here. It says if, watch this, get weight is less than or equal to 5. I'm going to put 5.0 to be specific because it's a double. So if it says if it's less than or equal to 5 pounds, the weight times the regular mail postage. Watch this. It's going to return get weight times, even say, well, how do you get the parents postage? Get the postage by calculate postage. Let this one sink in. You see, the mail, everybody calculates their postage and insurance. So if I'm in the box, I know for a fact my parent does this. I know from a fact that my parent does this because this get weight is at the very top and it applies to all. So if I go to my parent's going to do the work for me, okay? Calculate the postage. But I want to add one little piece to this. There's a word called super. So super, you've seen it before. It's two ways to do this. You can either use it inside the constructor or inside a method, and it always pertains to your parent. So right now what I'm saying is you could also do it here, but this will be a little silly because the get weight is not going to be overridden. Now, another thing that's important here, even though I have get weight here, I'm not going to override get weight because there's no reason to do that. Once you get the weight, you get the weight. But when I get down to the box, I'm going to override the calculate postage because each of these guys do their postage differently. So see, get weight is not a method to be overridden. So it's kind of silly to do super dot, but super dot is correct. So I'm going to take it off of that, but leave it on this. And then the other piece says, if that's not true, if it's not true, then it costs 50% more. Now, obviously, we are going to be thinking that the weight is actually positive. So we're not going to worry about that. So if when we say less than or equal to 5 pounds, we're thinking of like a 1 pound, half a pound, something like that. Okay, so it costs 50% more. So we got to return this, okay, this very thing here, but 50% more. So times 1.5. All right, this is what I call a partial override. I call that a partial override because, let me show you what I'm saying. This kid is doing the postage a little different to his parent, so he's overridden. Okay. This kid does not override at all. It does it exactly like its parent. So there is no need to write it. Actually, you know what? Let me show you a mistake. But it's not actually a mistake, but some people do this. Some people do this, and you can't do this. And you can't do this. You cannot do this. I'm going to say do not do this. Super dot calculate postage. Don't do this. And I'm going to return. Don't do this. This is very silly because the parent already calculates the postage and the child already inherits it. So doing this is silly, pointless. You don't want to do that. If you write code like that, you are doing something that is pointless. Just understand, if you're doing it just like my parent, do not override it. Do not override it. Just leave it blank. Just in your mind go, okay, it's doing it just like this. So right now it's returning $1. Obviously the regular box does not do that because it's different. Okay, well, let's go. A priority postage is $1.50 for any mail 1 pound or below 1 pound. Okay, so if you're below a pound, it's $1.50. Otherwise, it's the weight times 150. So let me go ahead and do the priority mail now. This guy says he has to see what the weight is. If it's below $1, I mean, it's not just $1, below 1 pound, then it's $1.50. So let's do that. Okay, remember, the get weight, everybody inherits it. So get me the weight. And if it's less than $1, we're going to return 150. Oh, by the way, I'm going to say something right now here. We could do this constant variable again. Private final double postage 150. And I'm going to return the postage. So I'm saying whenever you have a value that doesn't change, where we could, keep it as a constant. So we have this 150 if it's below. Other way is the postage. Its postage is weight times 150. See that? So if it's not true, then else return. We're going to say the postage, okay, which is the 150 times the weight. Get me the weight. See the importance of a getter? I'm overriding methods. How do I know? Because when I first did it, it was just $1. But as I go down the hierarchy, it's changing. So I'm overriding it. Partially because I'm actually using my parents in some instances, right? Like here. And over here, A complete override. See, no super dot. There is no super. I'm not using my parents' calculate postage to help me in any way at all. So you got to be careful here. You know when you have to override is when the parent postage is necessary for you to calculate it. So in this case here, I needed the parent's postage to figure out my postage. But over here, I don't. It has nothing to do with the postage. I'll wait. All right, let's go to the next one, which is we're going to do some priority mail. So it says the priority envelope is the same as the priority. So that means the envelope, don't do it. Don't do it because it's doing it just like the priority mail. If it's doing it just like your parent, no need to override. How about the box? How about the box? The box says it's $5 for anything below a pound. Otherwise, its postage is weight times the $5. Looks a lot like this guy, except the price changed, right? So I'm going to do the same thing. What I'm going to do now is go to the box and I'm going to create another constant, but this time it's $5, right? Not, and then it says, let's look back. It says if it's below a pound is 5 and anything else is weight times 5. So let's do that. So let's see. It's going to say if get weight is less than 1.0. Let's make sure we do that. I'm going to return $5. See? Right there. So I'm going to return the postage. Otherwise, I'm going to return the postage times the weight. Get weight. Overriding postage. That's what we're doing. Overriding postage. So right now, I just override the postage for everybody. Okay, realize I just focused on the postage. I kind of propagated all the way through, all the way from the mail, all the way down to all of its kids and grandkids. Everybody postage is now calculated. So now, here's the deal. We got to do the same thing for insurance. We have to do the same thing for insurance, okay? So all we got to do now is figure out, should I override, should I not? And here's what I'm going to do. I'm going to put it up. You can pause the video, get all the specs for the insurance, and see if you can figure out how to override the calculate insurance. Now, if you did pause the video and figure out how to calculate the insurance by overriding when you're supposed to and not, obviously all this information here is going to come into play. And you have to make sure you can do the insurance just like I did the postage, just from this information. Once you're finished doing this insurance, then you can figure out which ones to override and which ones to not override. I'm not going to write the solution just yet, but let's just look at this. Envelope mail. Insurance uses a formula for weight times postage times 0.15. That's for envelopes. For box mails, it's going to be weight times postage times 0.25. Now, obviously, we don't have anything for, what if it's just a mail and we don't know which type? Okay? What if it's just a mail and we don't know which type? So if I create an instance of a regular mail, what would be the insurance on that? That's the tricky part. We'll do that in the next video.